This is possible by partition. You must have heard about what is bipartite graph, like what is bipartition. Basically, bipartite graph is basically when you can color the graph using two colors only, such that adjacent vertex do not have same color. And that's about it. Let me show you the question statement. You want to split a group of n people. Okay, so you have a group of n peoples numbered 1 from empty, n is given, into two groups of any size. Okay, into two groups of any size means the size can be different also. Each person may dislike some other people and they should not go in the same group. So basically 1 and 2 should not be in the same group, 1 and 3 should not be in the same group, 2 and 4 should not be in the same group, right? And you have been given this integer n, total number of people. You have been given dislike array, who dislikes whom, and indicates that person a does not like the person b, and if it's possible to split everyone into groups, return true, otherwise false. So yeah, in the question statement they have not mentioned something about graph, about bipartition, but it's pretty much clear by looking at the problem statement that the problem is about bipartition. Because if you want to keep, for example, this is a dislike vector and there are four peoples, right? One, two, three, four, and 1 and 2 should be in the different group. So let me say this is G1, and let's say this is G2. So 1 should come over here, 2 should come over here. 1 and 3 should be in different group. Now 1 is already present in G1, so no need to add it again. But 3 should be in G2, right? And 2 is already in G2, so 4 will come in J here, G4. And it's possible to divide these people into two groups, right? Yeah. Now, 1, 2, 1, 3, 2, 3. This is not possible. Like, why? If there are three peoples, like one come over here, two come over here, and one is already there, so you just add three in G2, right? And then two is already here. Now you want to add three in G2, G1, sorry, but that's not possible because now two and three dislike each other, but they have to be in the same group. So in this way, it's not possible to divide them. At least you need something like three different, groups to divide them into. Yeah, but that's not possible, so we'll return false. Now this is a basic standard bipartite graph question. So let's start by making graph, uh, declaring it global because we'll be using another function, bool by, and sv. So this function will have something like bfs. I'll do bfs to color all the graphs. So q, and the color of, first let's create vectors, or int graph, right? And vector int call, and over here you will declare v dot resize, sorry, g dot resize, um, n plus 1 or n whatever you want. Based on that, change your indexing because they have given one indexing in this likes vector. What are you going to do? G of I of 0, or what you can do, I of 0 minus minus I of 1 minus minus. Now it's fine. Dot push back I of 1, and similarly 1 dot push back I of 0. After that, just resize your color vector. This is basically color vector. Okay? Call dot resize something like n, and everyone have minus 1 color initially, and you will call on for int I is equal to. Now you will check if bipartite graph, or basically BIP, starting from SV, you will start coloring. Okay? If it's not colored, okay, if color of I is equal to minus 1, like if it's not colored, start coloring this. Oh, okay, you have to write, not like start coloring this. Basically I'm calling on this BIP function. This will return true or false. If it returns false, okay, this is not possible to color it like this way. You will also return false, something like return 0. Otherwise you will also return true. That's about it. Color of I will color it by color 1, like the first node which will come. and then q dot push also sv, and color of sv was equal to 1, right? And while your q dot size exists, you will pick out the front, and then you'll do q dot pop, and then for auto I in all the adjacent of this sv, you will check if it's not colored already. Okay, if color of I is equal to -1, you will say color of I is equal to 1 minus color of this you know कहाँ से आ रहा है ये f से आ रहा है because oh sorry, this is not sv, this is f. So adjacent of this frontier which we took out, we'll just color it by different color. Basically 1 and 0 are the two colors which I'm using, that's for this. And then you can just q dot push I, and call on I, then I will check all its neighbor whether it's good or not. Else if agar color of I is already filled and it is equal to color of f, that's not possible na. Two adjacent cannot have same color, so return 0. Otherwise you can return false, sorry 1. Yeah, that's about it. Let's check it. Anything initialization which we have to do, q dot push I static, oh sorry, what is this, q dot push I. Okay, d is dislikes, n is basically given. The only thing is like this 0 to n which I took now. It should be good. It should be good because yeah, it should be good. Let's check it. Yeah, as you can see, not pretty good efficiency, but both the codes were same. I don't know what happened, but that's is just common with Leetcode. Let's move to GFG problem of the day. Absolute string list sorting. This is obviously easy problem and literally easy problem. In this, you have been given a you know linked list which contains some positive value, some negative value. This linked list is kind of sorted, not completely sorted. It's kind of sorted on the based on the absolute values of the data, like 1, 2, 3, 4, 5. This is absolute value, but 2 is not actually 2; it's -2. So you need to sort it like according to the actual data. So -5 should come first, then -3, then -2, and then 1 and 4. So it's pretty simple. Basically, you will iterate over the linked list starting from here. You will see which node has negative value. The basic logic behind this problem is like you have to see which is the negative value and push this negative value, not push, just like take out this negative value and add it on the front, like add it before the head. So -2 will get before the head, so -2 when, and then -3 you will see. Then you will change the head also, so now -2 is now head. So basically let me show you what I'm saying, because this is not a standard type of question, but it is easy type of question. So first when you see 1 is good, then you will go to -2, then -2 will say okay, I'm negative, so make it to the head and like push everything like this, -3, 4, and 5 like this, right? And then after that, now 1 was already checked, to -2 was already checked. Now you are at -3. So -3 will say okay, I'm negative, so push it at the before of head. Now head becomes this is basically point, head becomes -2 when I swap this, something like that. Not exactly swapping, I don't know, like can we swap it? I don't know. I don't think we can swap it. And then 4 and 5. And then this is not 5, this is -5. And then it will go to 4. 4 is already good. Then it will go to -5. -5 will come over here. -3, -2, 1 and 4. Like this, it will get completely sorted. So what you have to do, you have to enter, not enter, basically node star cur. I think we can swap values now. Hmm. Okay. Because let's say if I swap these two values, this comes like this. When I say okay, then swap these two values, no, I don't want to swap these two values because -2 will come over this place. I don't want this. So this is basically not swapping, but yeah, uh making the changes in the pointers, like pointer transition. So while your current connects, basically what you are doing, first of all, I'm my current is 1 and I'm checking the next pointer because like whether next pointer is negative or not. Okay. Now what if the current is already negative? So current is already negative, then it is only a good place ना कि -1 यहीं पे होना चाहिए और -1 यहीं पे है, दिक्कत ही नहीं है, right? Now we need to see from -2 basically कि -2 is also negative, then make it over there. So current dot next we are checking and we are saying कि let's store the next pointer of this basically -2 when come over this place. Now how will I say that 1 is going pointing to -3? That's why I need previous one. That's why I'm doing this current connects, or that's why I'm checking if कि तुम्हारा current के next का data is less than negative, not current का data but current के next का data, because current का मेरे को वो चाहिए, like I need a ट्रैक ऑफ करंट बेसिकली, बिकॉज उसके बाद अगर करंट का नेक्स्ट का डेटा नेगेटिव हुआ तो जब मैं चेंजेस करूंगा तो करंट को आई शुड नीड टू कनेक्ट विद करंट की नेक्स्ट डॉट नेक्स्ट. सो दैट्स व्हाई एवरीथिंग आई एम वर्किंग ऑन करंट एंड चेकिंग करंट का नेक्स्ट. ठीक है. इफ करंट का नेक्स्ट योर डेटा, सो नाउ यू शुड क्रिएट अ नेक्स्ट पॉइंटर ऑफ करंट के नेक्स्ट का नेक्स्ट, स्टोर इट, will need it, and then अगर करंट के नेक्स्ट का डेटा नेगेटिव है, सो करंट के नेक्स्ट को बना दो तुम हेड, लाइक करंट के नेक्स्ट का नेक्स्ट इज इक्वल बिकम्स हेड, राइट? सो नाउ 2 का नेक्स्ट बिकम्स द हेड एंड हेड बिकम्स 2, करंट का नेक्स्ट बिकम्स हेड. देन आपका जो करंट था इसका नेक्स्ट बिकम्स इक्वल टू एन एक्स जो तुमने स्टोर करा था. तो अभी क्या हुआ, हमने कहा कि ओके -2 वॉज नेगेटिव, बेसिकली करंट का नेक्स्ट वॉज नेगेटिव. सो ये हमने स्टोर कर रख लिया -3. फिर हमने क्या करा, -2 के नेक्स्ट को बना दिया 1 और -2 को बना दिया हेड. तो नाउ दिस इज माई हेड पॉइंटर ऑल्सो. दिस बिकेम माई हेड पॉइंटर, दिस वॉज माई करंट पॉइंटर एंड ये मैंने स्टोर करके रखा हुआ था करंट के नेक्स्ट में, एनएक्स में. ठीक है. सो एनएक्स पर अभी पॉइंटर्स कैसे डिसाइड है कि मतलब -1 जा रहा है, 1 तो कहीं नहीं जा रहा क्योंकि करंट का नेक्स्ट मैंने ब्रेक करा अभी तक नहीं. करंट का नेक्स्ट मतलब एक तरह से 1 हेड को पॉइंट कर रहा है, नहीं -2 1 को पॉइंट कर रहा है. एंड हाँ, तो बेसिकली मेरे को करंट के नेक्स्ट को नेक्स्ट पे पॉइंट कराना है. सो दैट्स अबाउट इट. एल्स इफ अगर ये गुड है तो तुम्हें कुछ नहीं करना, करंट इक्वल टू करंट का नेक्स्ट करते जाओ और आगे बढ़ते जाओ, समथिंग लाइक दैट. एट लास्ट यू विल रिटर्न हेड. दैट्स अबाउट इट. कट करंट. Anything else? Yeah, let's submit this. 12 minutes. Yeah, but both problem was simple. One was standard, just bipartite wala. This was not a standard, but very easy to intuition that you just need to make transition whenever you see the negative element. Make it to the front of the list, basically make it head and just go to the next. And then if it again negative, make it to the head and then again go ahead. So that's about it. Possible bipartition was just simple. Basically, this is a standard graph coloring problem, and just you need to check whether the adjacent color should not have the same color, it will return false. And like, yeah, that's about it. Okay, bye.